Okay, we're given two functions. We're given the original one and we're given the inverse. And it's asking us to find derivatives of each one. So you can either use this notation or you can use the prime notation. So I'm going to use the prime notation in this case. So the derivative of f of x, let's do that first. F prime of x. Okay, now this is going to involve the power rule. So 2 is going to come down, x, subtract 1, and then that's it. So that would be the derivative of the original one. You get 2x. Let's do that now for the inverse. So here's how you're going to write that notation. If you want to use the prime notation, this is how you'd write it. The inverse prime, that means you're taking the derivative of the inverse. Now this is going to involve a chain rule because I've got something inside here that's not just a regular x. So I'm going to write it as x minus 1 to the 1/2 power. That way I can apply the power rule to the outside. So the 1/2 is going to come down. I have x minus 1, subtract 1 from the original power, and then don't forget that you have to multiply by the derivative of the inside. In this case, the derivative of x is just going to be 1. Let's rewrite this. So I have the inverse derivative. It's 1 over 2 square root x minus 1. And there's nothing more I can do as far as simplifying. Now what I want to do is make a connection between the inverse and the derivative of the inverse. You want to take a look at both of those. So let's take a look at the bottom part because it's made up of things that we already have already. There's a 2 that's here, which matches the 2 that was originally in my derivative of f. I have a square root. The square root is actually part of the inverse. So what I can say with this bottom part, this part right here, I can say that that's the derivative function with the inverse put inside. It may not be obvious to see that right away, but we're trying to make a connection and try and generalize this, so this is kind of the way that we can do that. So again, you have the 2x is your derivative. If you take out the x, replace it with the inverse, square root of x minus 1, that's what you get on the bottom. So because of that, we can make a generalized rule. If you take the inverse, take the derivative of it, this is equal to 1 over this notation here. The derivative, and we're putting the inverse inside of it. So this is actually the general conclusion that we have when we're looking at inverses and their derivatives. So note that this is not f of the inverse and then you take the derivative, because that would be 1, because whenever you do the composition function, we talked about that earlier, you're always going to get x. It's not saying that. It's saying you're putting the inverse inside of the derivative function. That's what this is saying. So now that we've seen this, there'll be some other problems that we're going to do later in this section that have to do with this rule. So we're going to come back to this a little bit later.